giving to the SCR 1 and 2. Now firing angle now 120 degrees. So for 120 degrees firing angle, the voltage is nearly 52 volts and current is nearly 0.15 or 14. So you can see the waveform here. So you can observe the waveform here. So these were the current, these are the voltage. So you can observe the voltage waveform. So it is single phase off control. So that's sorry, it is a single phase AC voltage controller. You can observe one here, one here. So again, by varying the firing angle, we can get the variable voltage. So input is the fixed AC voltage, output is variable AC voltage. You can see the observe the sine waveform. That is here sine waveform, negative, positive, positive, negative, positive, negative. So this is the current waveform for RL load. You can observe this is the extension of the to negative side, negative angle. So this is the extension angle. Here also we get the so this is about RL load. Okay. Then now we will change the firing angle 90 degrees. At 90 degrees. For firing angle 90 degrees, voltage is nearly 83 and the current is 0.23. Now you can observe the waveform. Now the sine waveform is no change compared to previous case, that is 120 degrees. Now it is 90 degrees. You can observe the waveform, it is changed now. Okay, you can observe the waveform, negative, positive, negative, positive. Okay. So that is upper, that is there are two as anti-parallel. Okay. So for one waveform it connect to positive, one is negative. Okay. So that you will get the positive, negative, positive, negative. Now we will change again the firing angle up to 60 degrees. Now we will change the firing angle 60 degrees. Yeah, 60. For firing angle 60 degrees, the voltage is nearly 104. The current is nearly 0.3 or 0.29. Now this you can observe the waveforms. Compared to previous case, you can observe the sine waveform is now it is clearly observing. You can observe sine waveform. Okay. So this is the current waveform, voltage waveform, current waveform. Then now we will change the firing angle to 30 degrees. Yes, for 30 degrees, you can observe the voltage is increased. It is nearly 115 or 114. Now the current is 0.33. Now you can observe the waveform. The sine waveform will get the pure sine waveform. There is only small there is a change in this is the disturbance here. So now you can observe the waveform, sine waveform. Okay, for voltage is the current. Now I will again reduce to 0. Firing angle 0 degrees. Yeah. Now you can see the voltage. Whatever you give the full voltage, so input is 115. You can observe the output also is 115. Clear? Now the current is 0.33. Now you can observe the sine waveform. So whatever the input is sine waveform, we are getting the same output also sine waveform. So voltage waveform, current waveform. Okay. You can observe voltage waveform, current waveform. Now this is for RL load. Now you can see the readings. So these are the simple calculations for R load, RL load. Okay, so in this case R load. In this case for alpha is taken 30 degrees. So you can also take VM. VM is input is 115 RMS into root 2. So then you get VM voltage, that is maximum voltage. Then substitute the remaining values. So alpha is taken 60 degrees. Okay, so that is alpha 30. 2 into alpha means 60 degrees you will get here. Okay, here beta minus 2. Okay. So this is for R load. How much current I0 you got? 0.29 for alpha equal to 30 degrees. Now you can observe the waveform. So input is a sinusoidal waveform here. We are given the firing angle for two SCRs, SCR 1 and 2. Now you can see the voltage waveform at voltage waveform. This is taken for nearly I think alpha is 90 degrees. Okay, so voltage current. Similarly for RL load. So you can observe there is extension again because the inductor will store the energy, so it will continue to some, the current will continue to flow for some time, so that's why we will get the negative here. So after some it will again reach 0. Okay. So this is for voltage and current. You can observe in R load, the R load voltage and current waveforms are same, because in R load, that is in resistance, voltage current both are in phase. But you can observe here in RL load, the inductor current lags the voltage. That's why you can observe here a small change in the current waveform also. Okay. Then you can see the table column for R load and RL load. So R load we are taking the 30, 60, 90, 120, 150. So these are the theoretical values, these are the practical values, theoretical, practical. Similarly, for RL load, we are taking the same firing angle. So this is for theoretical values, practical values. Similarly, theoretical, practical values. Okay. So these are the readings. So just you, by seeing this video, you just to copy and to your record. Okay. Thank you.